Good morning. This is Unit 3, Day 5, Equation Solving and Modeling. The first thing says use the order of magnitude to compare any like quantities. Remember, we use exponentials and logs in our everyday lives, so this is an application. The Riker scale model is R equals, and it's log of A over T, and then plus B. And this measures the magnitude of an earthquake. A is the amplitude in micrometers of the vertical ground motion at the receiving station. T is the period of the seismic wave in seconds. And B is a dampening of the seismic wave as the distance from the epicenter increases. So where the earthquake starts or begins from. The pH scale model is pH, like this, equals negative log of, and then of H. So let me just make this like plus. This is a scale that measures how acidic or basic a substance ranks. It ranges from 0 to 14, where 7 represents a neutral, and anything below 7 is 10 times more acidic than the next higher value. Newton's law of cooling is another one. It is T in respect to T equals T of M. This is the temperature, plus of the surrounding medium, plus T sub 0, which we know is our initial, minus T sub M times E to the negative KT. Okay, and our T is going to be time. So we have one-to-one properties. So this says if we have a function f of x equals b to the x, if b to the u equals b to the v, then u has to equal v. The exponents have to be equal to each other. If the bases are equal, the exponents need to be equal. For any logarithmic function, if we have log base b of u and log base b of v, then again u has to be equal to v. The expressions need to be equal. Alright, so what we're going to do is solve these. These are going to be a little bit more complicated than last time. So I'm first going to try to get my base, or the thing that has the exponent, by itself. So I can divide this 24 over to get rid of it. Divide both sides by 24. And this 24 divided by 24 is just going to give us 1 times this. So we're going to have 1/2 to the x over 3 equals 6 over 24, I believe, is 1 over 4. Tell me if I'm wrong. And now I need these bases to be the same so that I can set the exponents equal. Well, 1/2, I can't really simplify this to make it 1/4. So I'm going to rewrite this as 1/2 to the x over 3. But 1 over 4 is the same as 1 over 2 squared. And what I can do is just kind of take out or factor out this squared, and this is the same as 1 over 2 to the squared. We have to have the same base. So 1/2 is equal to 1/2. That means the exponents need to be equal. This one is not as easy as our last 2 days. So we have x divided by 3 has to equal 2. Right, what does x have to be? What I would do, truthfully, is like cross multiply. It's the same thing as if you multiply both sides by 3, which is the denominator. Either way, x times 1 is x, and 3 times 2 gives us 6. Alright, this one says solve this equation. Remember that pi is not a variable, this is a number. It's just so popular, it has its own symbol. So we're going to solve for x. The only variable in this is x. E is also not a variable. So what I would start off with is getting rid of something. I think we're going to get rid of e first, because this one we have a natural log. It's very special. We're going to use that. So natural log of both sides. Take the natural log of both sides. If we do something to the left, of course, we have to do that to the right. So the natural log of e, remember those cancel, and we're just going to get 1 times the exponent. The exponent is x, equals the natural log of pi. Unfortunately, is not anything nice. So we're going to say natural log of pi to the 1 plus x. But since, well, I'll just put it up there for you. So one of our properties of logs is if we have an exponent, we can pull it down in front. This whole thing, though, has to come down in front, in parentheses. So we have x equals, parentheses, 1 plus x times the natural log of pi. What I'm trying to do is get all of my x's to one side. And in order to do that, I'm going to actually have to distribute this natural log. So x equals 1 times natural log of pi, which is just natural log of pi. And then x times natural log of pi, which is just x natural log of pi. I want all of my x's to be on one side. So I'm going to actually subtract this term to move it to the other side. Minus x natural log of pi. Whatever I do to the right, I have to do to the left. Minus x natural log of pi. I'm trying not to skip too many steps. So this is what I have so far. X minus x natural log of pi equals, the right hand side still has a natural log of pi. Right, now I have all of my x terms on this side. What I'm going to do is I'm going to factor out an x. And what I'm left with, don't forget this, I need to put a 1 here for a placeholder. So if I distribute it back in, I have to get this again, right? So 1 minus natural log of pi equals natural log of pi. And what I'm going to do is I'm going to divide by this. Divide, I'm trying to, whenever I have something multiplied by my variable, I divide by it. And that is your answer. This is a calculator thing. I wouldn't even know what this is. So I'd have to put it in the calculator. Whatever natural log of pi divided by 1 minus natural log of pi is. Okay? I think it's negative. But you tell me what it is. Plug it in your calculator. Tell me the decimal. That's my answer. Alrighty guys, let's try another one. This one, you guys see this one is 2x and this one is x. This is actually just like a quadratic. If it's easier for you guys to pretend like e to the 2x is x squared and this is negative 3x minus 4, you can go ahead and do that. And then maybe you substitute it back in. But I know I know that e to the x and e to the x is the only thing that gives us e to the 2x, right? Because when we're multiplying, we actually add our exponents, and x plus x is 2x. My factors of 4 are 2 and 2, and 1 times 4. But which one will give us a difference of 3? 2 and 2 won't, 1 and 4 will. So one of them's 1, one of them's 4, the order doesn't matter. But now I need to put in the signs. When I multiply, they have to be negative, but when I add, we need a negative 3. So my bigger one needs to be negative, and my smaller one needs to be positive, because a negative times a positive is the only thing that'll give me a negative 4. Alright, so set it equal to 0. We still have it equal 0 on the right-hand side. Now, after we've factored this, you can FOIL it and make sure, but this is factored. We have to set each term equal to 0, so we have e to the x plus 1 equals 0, and then e to the x minus 4 equals 0. Move the 1 over, e to the x equals 1. When does an exponential equal 1? I'm sorry, negative 1. Does an exponential ever equal a negative number? This is not going to be a solution. This is never a thing. So I'm going to cancel it, cross it out. What about this one? I'm going to have to add the 4 over. So this one's okay. E to the x equals positive 4. This one's good. So what I'm going to have to do to solve for x, though, is like a little mini equation. I'll have to take the natural log of both sides, because that's the only thing that's going to get rid of this e. So I can get x equals something. Natural log of e is 1, so I'm left with my variable, which is x, equals natural log of 4. So we're going to go back to our calculator, and I'm going to put in natural log, of 4 into it, and I get 1.38. Oops, 1.38, sorry. It didn't work. Okay, x equals 1.38. Okay. Well, let's keep going. This one, in order to solve this, I need to first get rid of this denominator. So I'm going to multiply both sides by 2, or cross multiply, same thing. If I put a 1 under here, I can cross multiply both sides by 2. So I get e to the x minus e to the negative x equals 16. So this is really cool. I want you to put a star by this because this might be a test question. And it's you might not know how to do it unless you saw me do this. So this e to the negative x is the same as 1 over e to the x. And what I want to do is actually bring it to the numerator or get rid of this denominator. So what I'm going to do is I'm going to multiply both sides by e to the x. Both sides. As long as I do it to the right and the left, that's okay. I'm not changing my equation. Now e to the x times e to the x is e to the 2x minus e to the x times e to the negative x is e to the x minus x is 0. And then this is 16 e to the x, right? Now anything to the 0 power is 1. There's a minus right here. I'm going to move this term over. So I'm going to subtract 16 e to the x's. So this is my equation. E to the 2x minus 16 e to the x, and then this is 1 minus 1 equals 0. And this is just the same as number 3. I need to factor it. But I don't know about you, but I don't know what factors of 1 will give us a difference of 16 or a sum of 16. That's not a thing. So what I'm going to have to do is see if there's any rational or imaginary solutions. What I'm going to do is use the quadratic formula. But this time, it's not x equals. It's e to the x equals. So usually it is x equals negative b. It's already negative 16, so it's positive 16 plus or minus the square root of b squared minus 4ac AC, okay, all over 2a. Okay, just drew this too far. Okay, so this is a calculator thing. I'm just going to try to simplify it a little bit. It's something like e to the x equals 16 plus or minus the square root of, this is squared, sorry, 256 plus 4, right? Okay, so 256 plus 4 is 260 all over 2. This I would put into my calculator, okay? But I'm not putting just this into my calculator. In order to solve for x, I need to take the natural log of this. And I need to take the natural log of this. You're going to have to do it twice, because you're going to have to do it 116 plus the square root of 60 over 2, and then the next one 16 minus the square root of 60 over 2. Okay? So x equals the natural log of 16 plus the square root of 260 over 2. And x equals the natural log of 16 minus the square root of 260 over 2. Okay, so that's going to be answers. Just 2. Maybe one's extraneous. Check it out. Okay, let's try this one. So, this is our property of logs that we learned, and we're going to have to combine them. But if it's a plus, then that means that we're multiplying. So we have a natural log of 3x minus 2 times x minus 1 equals natural log of x squared. So I'm just like bringing this 2 up to be an exponent. This I'm going to have to actually FOIL. Oh, this, so natural log of this, natural log of this. I can cancel these. I can take the e, raise it to the base e on both sides, cancel them. And I'm going to FOIL this. So this is 3x squared minus 5x plus 2 equals x squared. Move your x squared to this side, so you get 2x squared minus 5x plus 2 equals 0. And then I'm going to have to factor this because I have a quadratic. I know one's going to be 2x and then one's going to be x. The factors of 2 are 1 and 2. I'm going to try this one, but I need to get -5. So I'm going to say negative and a negative, because a negative times a negative is a positive, and a -2 times 2 is 4. -4 minus 1x is -5x. So you can FOIL it and check it out. But in this case, I get 2x minus 1 equals 0, and I'm going to add the 1 to move it over, divide by 2, x equals 1/2. And this one just x equals 2. X equals 2 will work, but if I get 1/2 in here, 1/2 minus 1, this will give us -1/2 in an expression. So I have to check these. I have to be careful and check these answers. And this one is actually doesn't work. It's called an extraneous solution. So I'm going to say EXTRANEOUS, extraneous solution. There's going to be one on this one too. I want you guys to try it. Remember that plus means we're going to multiply these. So order of magnitude and logarithmic models. You guys can do this. Just plug it into your calculator. The pattern. So I actually had to plug it in to see what the pattern was. So I'm going to plug this in. I got 1.4, 1.477, 2.447, 3.447, and it kept on going, and then we got 10.477. And this, it says, what is the pattern? The pattern is 1, 2, 3, all the way to 10. Okay, you guys can try the other two. So this one says, comparing the earthquake intensities. I have seen this on the SAT, so I'm going to go over it. It says, how many times more severe was this earthquake than the other? And this is what we're going to do. We're going to say R1 minus R2. We're going to see how much bigger it is or how much more intense. We know that the formula for earthquake is log of A1 over T and then plus B. But we're going to subtract the R1. So subtract the R1 from R2. Okay, so log of A sub 1 over T, so plus B. I'm just going to plug in the things that we know. All we know is that the R1 was 7.9 and the R2 was 5.9. But that's really all we need. Watch. So we have log of A1 over T plus B minus, I'm going to distribute this negative, log of A1 over T also. Sorry, I keep on doing that. A1, this is A2. This one is going to be minus B. I have to distribute this negative, but it's going to be minus B. Alright, now the B's will cancel. And since this has a negative in front of the log, I can combine these expressions and I'm going to divide them. But A1 divided by T, A1 over T divided by A2 over T, we multiply by the reciprocal, the T's will cancel. And we're going to get, this part is 2 equals log of A1 over A2. Now all I need to do is get rid of this log. What I'm going to do to get rid of it, since it has no base, I know that the base is 10. I'm going to take the 10 base 10 of both sides. 10 to the second power is 100. So India was 100 times greater. Than Greece. All right, this is the last one I'm going to do today. Wait. If you guys have any questions, please ask me. Have a wonderful day. Bye.